There we are. That's a jazz standard I just made up. Well, I've got that now recorded here, so if I feel like it at some point, I can throw together a four-piece and go around going. How you doing? Hey, Matt Todd. Hello or hell? Which is it? Is hello or hell? I hope it's a hello and not hell. Hell. Oh. A GeForce Game Ready driver is available. I only updated it like the other. It's like, go away. GeForce updated thingy, blah 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 blah. How you doing? What's happened? Why is that jumping around? Oh dear. It's catchy, that. Anyway, right, where was I? So I'm trying to get a routine going. My routine is I come home from work, I have something to eat, and then I do music, as I've been neglecting my music. And that's no good. Oh, hang on, virus and threat detection. Windows Defender found nothing. Okay, it just pops up to let me know that. They didn't find anything. Just to remind me that it's there. It's eating up system resources and slowing down my computer. Yeah, it's important for it to remind me of that. So yeah, routine is going. I'm going to try and get some routine going. The routine, I'm a bit behind schedule tonight on my new routine, but it's to start streaming at 10 o'clock UK time, which gives me time to do some music. So I did a couple of hours tonight, which was good. I was working on a song called I Know Why the Caged Bird Sings, which was inspired by the book of the same title. Well, it was actually inspired by the title of the book of the same title. And that was it. And I was trying cello on it. I just heard, Matt, hey, Matt, and then you freaking YouTube. Yeah, I bet. YouTube pros. Right. Well, yes, not when things worked for most of the time. That's right. That's right. So civilization will end not with a bang, not with a whimper, but with a blue screen of death. Can you believe today? Because I just started new work, new job. Yeah, cool people. Well, I think I'm going to enjoy it there. And you know, they've got new PCs in. It's no fault of theirs. You buy a PC. You buy a PC. You expect the PC to work, right? You know, you expect the PC to work. I got a PC and it was blue screening. It's just like, what? I had to get another one. They had another. But can you believe that? It was a blue screen. Seriously. There I was, minding my own business. Blue screen of death. And then there was other weirdness going on. There was like lots of little ghosts in the machine today. You know, I'm just sort of waiting here to see what's going to break next. Yeah, no, it was good. It was good. It was fine. Set up things, and you know how it is. You know, install Unity, install software. Spend all day installing software. You hope it works. But yeah, but you remember my problems I had with my PC. It kept blue screening all the time. So far, I've had one blue screen and this guy. I'm convinced that the computer was, you know, cursed. But this one, the reason that that blue screen was because, well, something had broken. Yeah, you know, the temperature sensor on the motherboard is broken, so I have to run speed fan, and speed fan wasn't running or something, and the CPU overheated and it blue screen. But that's the only time. Oh, I've got it running now. I don't know if there are any fans as such, but it's kind of nice if nobody makes too much of a fuss, because it makes me nervous, to be honest. It makes me nervous because I never know how to behave. It's like, you know. Oh, maths. Well, I was going to do, you know what? We could do maths. Trying to learn math and trying to understand the equation ax plus by plus cz plus d equals 0. Now, that's interesting. Let me think. It would be the equation of a plane, I think. Am I right? Because I know ax plus by plus c equals 0. I was experimenting with that the other day. That's without the z. I was experimenting with that the other day. And I was looking for the... it's really interesting. It's an interesting topic, right? Because I have this bone of contention with maths education, as you may know, where just one of the things I like to rant about, the fact that maths education is basically useless a lot of the time. And this one of the, you know, my examples of uselessness is this equation, which is always taught as y equal mx plus c. You always see it this way, and it's always mx plus c. It's never ax plus, in fact, maybe it would be served if people just did it as ax plus b, or if sometimes they just randomized which ones they use so people would understand algebra more quickly. But the form of it, because then they think it has to be an m and a c, but it could be anything. So, you know, y equal mx plus c, you could also write as y equal ax plus b. And it's the equation of a line, but it's a lie. I mean, yeah, it's true, it is the equation of a line. I mean, but it's a useless equation of a line. It's a really troublesome equation of a line because you can't do a vertical line. So because I was working with, experimenting with shaders, I was looking for, I think it's called a closed form, which is that equation that Matt Codd has put up there, ax plus by plus cz plus d equals 0, I believe is called the closed form equation. I mean, you know, maybe I used the wrong terms, but in the closed form as opposed to parametric form, it's, you know, the lovely example that you can get Desmos very easily to show is this one, y squared plus x squared equal 1, and it creates a circle because that is the equation of a circle. It's all the points that are exactly 1 unit away from the center, which you can see from Pythagoras that would be the case. It's like, you know, it's like x squared plus y squared equal 1. So this closed form of the equation of a circle. Hey, Mike. Oh, I missed you there. Sorry. I actually didn't I thought you were Matt Codd for some reason because the text was all blue. How you doing, Mike? So you can do the parametric form of the equation, which is the thing everybody's probably more familiar with, isn't it? Is a cos x, comma, sine x. Yeah, well, maybe I need to do it this way. Isn't that right? No, hang on. What am I doing? Wait a minute. No. I was right the first time. You do, and you have to say t. If I say t to Desmos, if I say t, then Desmos will change the value of t between 0 and 1, and what you get now is part of a circle with the cosine and sine is between 0 and 1. So if I go between 0 and 2 pi, then I actually get a circle. So there's another way of drawing a circle. This is use the parametric method, where you have the x and the y driven by some other parameter t that sweeps over a particular range. And you can have the parametric equation of a line, and the parametric equation of a line would be something like, let's see, parametric equation of a line between 2 points, where points are, say, x1, y1, and x2, y2, would be something like this. It's x1 plus x2 minus x1 times t, because when t is 0, then it's going to be x1, and when t is 1, you're going to have x2. You see that? And so it's going to sweep the x-coordinate between the 2 points. So we just repeat this, and we do the y, y1, y, y2, y2, y, blah, blah, blah. And we need the points, and so let's add the points in there. That's kind of interesting. Yeah, let's do it a different way, because I want to be able to drag the points around. So if I go in here and I say, so x1 comma y1, there we are, and I've got a point, and then I can say x2 comma y2, and I get another point, not y2, y2, x2, y2, x2, y2, like so. And now I've got, and it's lovely, because what I've got now is Desmos's drawing. Still trying to understand the reward achievement talk. But there isn't much to understand. Like, all I was basically trying to say is that a reward is an illusion. And achievement, the sense of achievement, is also an illusion. And it's okay to enjoy the illusion, but you should never really forget that it's an illusion. Anyway, a bit like life. So what you've got now is I can drag these two ends of this line, and the reason why you end up with Desmos drawing a nice line in between is because it's plotting all the points for t in a range of 0 to 1. In fact, if I go and change this to, say, 0.5, now it's only going to draw the line halfway, which is kind of cool. Yeah. See? Or I can go, say, minus 1 to, say, 2, and now it's going to extend the line beyond that. So this parametric equation of a line is very useful, because there is a kind of a flow of consciousness thought process going on here. We can have a vertical line. That's lovely about this parametric equation. The parametric equation of the line is that it handles lines in any direction, like a vertical one. Because here t is going to be moving from 0 to 1, and the fact that it doesn't move in x doesn't matter, it moves in y. It's all very straightforward, you know. Lovely. Go back to this horrible thing. This cannot give you a vertical line. Because if you want a vertical line, you have to make A really, really big. And that's almost a vertical line, but it isn't really. You have to make A infinite. And that's why this is a really horrible way of representing a line. It's pretty useless. So, so what I was thinking then the other day was, well, you could just look at this equation and see, well, maybe we can rewrite it a little bit. What about if we rewrite it we do a different equation. Ay, well, I'm going to need different parameters now. So, okay, let me just clear these little bits out here. And then what I'm going to do is write a new equation, which is ay plus bx, and you can see this is where Matt Codd's thing comes in, plus c equals 0. And this, I know, is this. It's the same form, except here you assume y is 1. But if you make y, you can have y anything you like, then let's just turn off everything else that's a distraction for a minute. Then a wonderful thing happens. Because suddenly, just by doing that, it becomes possible to have a line in any direction without needing to use infinity. So I was experimenting with trying to do a line segment. That's, you saw a line segment here. Where was that? There. This is a line segment. To try and do a line segment using a closed form, a closed equation for a line segment as a closed form equation. This is the equation of a line in a closed form, but it's infinite because it goes off forever. So to actually limit it is a little bit kind of messy, but it's relevant for shader work, right? Because when you want to draw a line with a shader, there are a few ways of drawing a line with a shader, but if you want to draw a line with a shader, you basically can't use the parametric form. Where most of the time to draw a line, you use the parametric form. You go and say, oh, I took a loop and I change the value of t and I plot the points, boom, 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 or I draw the line, whatever, boom. But you don't do that with a shader because the shader doesn't have the parametric value. What you have is just, here's coordinate x, y, should there be a line there or not? So if you use this form in a shader, and as you get closer to 0, you make it brighter, you make the pixel brighter. You can see how you can draw any line, but not a line segment with that. Add a bit of some if statements in there, and you can do a line segment as well. But this would draw a line in space for the set of values along x and y. So it works very nicely in a shader. So that's it. So anyway, where was I going with this? Well, this is then, you could say, the general equation of a line in the more mature form and sensible form than the one they taught you at school, which is y equal mx plus c. You can have ay plus bx plus c equals 0. And as you can see there, blah, blah, blah. Does mean that for any particular line, there is more than one solution to what a, b, and c should be. It's kind of ambiguity. But the reason it allows you to, put your lines in absolutely any direction is because there's always going to be a reasonable values. As you can see here, I don't have to make these values really big to find a line. That your satisfaction lies in your illusion, but your delusions are yours and not mine. What's that? Where does that come from, Mike? So, right, now to get to the other point there, is that Matt Codd's formula was ax plus bx plus cz. Now, ax plus by plus cz plus d. And there you go. It can't plot this one because this isn't a three-dimensional plotter. But if you imagine that there was a Desmos that worked in three-dimensional space, which would be pretty cool, then what you would have here is a plane. Because what you've got is all of the points, just like here, you're defining all of the points in two-dimensional space which lie along this line by satisfying this equation. That is, there are only a certain sets of values in of x and y here. There are only certain sets of values in x and y here which correspond to a point in this two-dimensional space called the plot. There's only certain values where this is true, and that's where you see the line. Now if you go to this one, yeah, it should be equal 0. It's interesting, it seems to be trying to, well, you see, that's the thing. There is a line here that's plotted, but that's assuming that z is 1. And if I change the value of z, this is actually moving, which makes sense because, as I was saying, this is a plane. because there are only certain values in 3D space which satisfy this equation, right? There are only of A, yeah, it doesn't understand Z because it doesn't have the ability to plot in 3 dimensions. Yeah, because it's 2D, exactly. But think about it, then you've got X, Y, and Z values, which could be anything in 3D space, you know, X, Y, and Z. And that, there are only, for any given values of A, B, C, and D, there are only certain combinations of X, Y, and Z which satisfy this equation. So it means that that is true for those values. And if you laid them all out, you'd find they make a plane instead of a line, because you've gone up from one dimension from a line to a plane. And the orientation of that plane is entirely defined by those 4 values, which is kind of interesting, because when you think about it, it means, well, it's like you define a plane with 3 values. Does that not make it sound familiar? What would happen if you make D 0? Then you define a plane that goes through the origin. That is, it's a plane that has 0, 0, 0 that satisfies the equation. Now you can see that. If I get rid of D here, you can see that clearly if I don't have D, then X, Y, and Z, all 0, always will satisfy this equation. So that's a plane now that goes through the origin. And you've got these 3 numbers. So now I'm wondering, you know, do they correspond to, like, you know, a 3-dimensional vector perchance? Yeah? So it's like, oh, if you have a normal vector, so doesn't that make the equation of a plane the normal vector A, B, C is like, this is actually NX, NY, NC? I wonder. NX, NY. I think it is, but I've never actually thought about it this way, to be honest, before, so I would think so, though. It would be, yeah, because if you had normal, say 0, 1, 0, and so NX is 0, NY is 0, is 1, and NZ is 0, then this equation would be satisfied no matter what values of N, of X and Z, as long as Y is also 0. So it's actually now, the plane is this. 0x plus 1y plus 0z. That defines a plane going through the origin. That defines a plane going through the origin that is in the xz plane, because this, all points where y is 0 satisfy the equation. Does that make sense? It's kind of interesting. Little detour there. Let's have a look. Yeah, when I look at this, it looks like it's been inspired by Desmos. Maybe it is. We'll try it out. Oh, this will be fun. AX squared. No, AX plus. Yeah, it definitely looks like it's inspired by Desmos. Plus AY. AX plus BY, sorry. Plus CZ plus D equal 0. Create slider. Ooh, I'm so excited. I'm laughing. That's awesome. Oh, nice find. So there's a 3-dimensional version of Desmos. There we go. And we can prove, I can show you everything I was saying then. Look, I'll go and make this 0, 0, 0. Can I make this 0? And so now it's a plane going through the origin. Look, oh yes, oh yes, oh yes. And then well, we'll set C equal to 0, and we'll set A equal to 0. And now you've got what? Depends on which way they have them. I think here they use Y that way. Well, okay, the green one is Y. So you can see you've got, just as I was suggesting, oh, you can make it spin. My thing is a bit confusing though. Can I stop spinning a minute, please? You're making me dizzy. What I don't understand is why I can change this and it's not changing the position of it. Oh! Yeah, because it's not going to. Yeah, it doesn't, sorry, it doesn't matter because it doesn't matter what the value of B is. Because, you know, you only get the plane when Y is 0. You can set Y to the up axis, can you? Show plane, snap, settings. Y is vertical, thank you. What did it do there? Y is vertical, that was all I wanted. The verticality in the Y, which is interesting as to why, now that Y is vertical, it's flipped a thing. That bit I don't understand. Anyway, whatever. Let's delete this because now we can have some real fun. Predict what will happen. So you saw if I do x, I don't know what will happen here if I do x squared. Oh, look. It's just like Desmos, but in 3D. X squared. So it'll be interesting to see if this actually can handle this. So x squared plus y squared. Ooh, ooh, whoa, look at that. Oh, awesome. X squared plus y squared equal 1. 1. Oh, right, I get it. X squared plus y, where did it go? Can I see it, please? Maybe it's a bit buggy because I can't see it anymore. It was there for a moment, I saw it, and then it went away. X squared, X, yeah, nothing ever, you know what we were saying about things don't work anymore? It's like, it doesn't work. What happened? I think it likes to have a Z. You saw it for a moment there. I think that's a bug because I saw it for a little moment, or maybe I need to just get rid. Ah, there it is. I got it. So Z is the blue one, X is the red one. You're looking at it saying, why? I was expecting a circle, but I didn't get a circle. What I got was a cube. Why? Because the values that satisfy the equation, if you consider X, Y, and Z, it doesn't matter the value of Z because Z doesn't appear in the equation, and so therefore you get an infinitely long tube. Which is interesting because it means the equation x squared plus y squared equals 1. We think of it as meaning a circle, but if you take exactly the same equation and put it into 3D space, you don't get a circle, you get a tube. Kind of interesting. So, yeah, that's cool. So what, of course, here's the thing though. Let's have all the points in 3D space that are exactly 1 unit away from the origin. And so now what you've got is the equation of a sphere. Are you going to do it? Ooh, I don't know. I don't know why it's did this F. Can you do it? Will it do it? Well, it did. Look at that. That's amazing. It's a sphere. Because just like you can have the equation of a circle, you can have the equation of a sphere. Nice find, Matt Cod. I like it. Would you like the equation of a four-dimensional sphere? The equation of a cube. Hi, John. Oh dear, it challenges. The equation of a cube. That's funny you should ask that, because I had to work out the equation of a square in order to do for a shader. The equation of a cube, when you think about it, you're looking for, well, let me do, use Desmos, I'm more used to the interface of Desmos. We've got x plus y equal 1. We get that line, but I can actually do the absolute value of x plus the absolute value of y equal 1. I'm just, whoa. What on earth? Nothing works, Matt Cod. Nothing works anymore. There we go. So what I've got is, and this is a cute little equation where the absolute value of x plus the absolute value of y equals 1. And that's all these points. So you actually get a square, but it's rotated at 45 degrees. So if you really want to sort of twist that around, you can do a coordinate transformation. I don't know of a good equation that works well the other way, but if you do it this way, it's a little cheat. So now let's try that. I know if this has absolute, we'll have to see. Absolute x, it does, plus absolute value of y equal 1. And ta-da! The only thing is that it technically, right, what should happen here is that should be infinitely long along the z-axis, because I didn't specify any z. So there's a little bit of an inconsistency there that I'm unsure about. Now, I've never thought about this before, so it's quite interesting. Can we turn this into a cube? Well, let's just see what happens. Ooh. You know, I don't know. I'm just going to try add the absolute value of z. Oh, it doesn't seem to like it. Plus absolute value of z. Yeah, there'll come a point where the thing will just tell me to sort of like, not so politely, bugger off, because it doesn't implement. Yeah, it really doesn't want to do this. How about if I write it out like this? Absolute x plus absolute y plus absolute z equal 1. All right, I managed to get the equation into the thing. It kind of resisted me, but I'm not seeing anything. Maybe it says there's no solution. You can turn off the plane in settings. Okay, in settings, show plane, where's the plane? Where's the plane, plane, projection, grid, show axis, basic axis, style, lighting, first menu, second item. I'm obviously being really dumb because I don't see it. First menu, Show object. I don't get it. When you click on the icon, okay, oh, user interfaces. I got it. Thanks. So what's a little disappointing that this doesn't work? X squared plus y. It may be though that it did. You could look it up. Closed form equation of a cube. No, that's not the same thing. No, right, that's interesting. I think you've asked a question that nobody's answered. Well, logically, okay, well, let's experiment then. If I just do this, then I get that. What is that? It looks a little messy, but what it actually is you can see how as x and y get bigger, you get values of z that get bigger, and that's almost like 1/2 of the cube. So I'm kind of thinking, wow. If I was to that's the reason it didn't show anything when I did the z. Oh, see. Oh, you know. I think it's a limitation of this graphing thing, because I think you can actually. I think it should do it. It's easy. Just install Boost. That's everybody's solution to everything, isn't it? You know, it's like C++ questions on Stack Overflow. How can I do blah, blah, blah? Easy, just install Boost. Yeah. 2,000 likes of that response. I said, just use Boost. Yeah, absolutely, Boost. Everybody. And the guy gets a load of reputation for saying Boost. Gets a boost to his reputation for saying Boost. So I really do think that if I delete this, can I delete that? Delete? Oh, it doesn't work. Can I delete that, please? Delete. Delete. No, it won't let me delete. It's a little buggy. Reload. Hey, Pete, how's it going? X plus. We're having a little maths fest here. Oh, that looks pretty, doesn't it? Okay. Plus Z. It doesn't like it, which is a great shame, because I can't prove it, but I believe that this formula, I can prove it to you even without this thing, because it can't handle my 3-dimensional cube. I'm trying to solve the poser suggested by John there. And we can get the equation of a cube. But let me do it here. I had this, right? Let's try the formula that I am suggesting, which does a three-dimensional cube. But of course, Desmos is not able to plot it in 3 dimensions. However, look at this. I can show slices. So this is proof. I submit this as proof that I have an equation for a cube. It's just it's rotated 45 degrees, but it is the equation of a cube. And this is because for values of z, hang on. For values of z outside the range of 1 to -1, you get nothing. There are no points. You have to imagine it's just a 3D space and I'm displaying a slice. So anything outside the range of -1 to 1, you don't see anything. And then as I get less than or greater than -1 to 1, in that range of -1 to 1, and I can just hit this here, and it's just going to do it, animate it. What I'm doing is going through a slice of my cube in that range, and you can see that that is exactly what you would expect, isn't it? So there you are. That's a 3-dimensional closed form cube equation. Of course, you go and say, hey, you know, but you want it rotated. Okay, you want it really? You want it rotated. You want it rotated. What you can do, shall I rotate it? Let's do an arbitrary rotation. That would be x cos angle A plus y sine A. And over here we would have to have x or y cos A minus x sine A. And we can add a slider A, and then I'm able to rotate this, see? So then, of course, for the correct rotation, which would be pi 45 degrees, or otherwise known as pi over 4, the only thing is that the dimensions of the cube is no longer quite correct. I did figure that out the other day. There was something quite nice. I can't remember exactly what that was nice, but this is 1 over the square root of 2, I think. But anyway, you just go. So the only thing is that that's wrong now for the values of z. So the cube is rotated. Yeah, it's rotated. That's why. Oh, yeah, because I've rotated it in this way, but in the z dimension, it's actually, yeah, not rotated. Interestingly, if I was able to rotate it, what you would get then is that as I move through the cube, it wouldn't change size. Oh, that's got very interesting. I don't know if I can, what I will do, you can combine the rotations, but I don't want to put my brain through the stacking of transformation. So what I'm going to try is something else. We'll do, if I put this back the way it was, I'm just curious then, because then what will happen if I rotate in the Z is going into the screen, so we're going to do it in the ZY plane. I can do Y cos A plus Z sine A and X. Ooh, what kind of weirdness, huh? Z sine Z cos A minus Y sine A. That should be rotating the cube. Oh no, right, okay, yeah, because it was like this, so it's actually that's correct. I've rotated the cube 90 degrees, or 45 degrees, sorry, I rotated the cube 45 degrees like this, but it's still on its end. I would need to do a second rotation. Oh. Yeah, it's on its point. Oh, okay, okay. By the way, this technique that we're seeing here, because John asked a question, what's the equation for a 4D sphere? I'll do that in a minute. But the interesting thing is that what we're doing is we're viewing the third dimension by looking at slices in 2D space through the third dimension. So this gives you a way of visualizing a 4D object. It's freaky. You can visualize a 4D object. You can use your imagination to look at that and figure out the 3D shape, because they're slices through, we're looking at slices through the 3D shape. So yeah, sure, fine. So what happens if you do slices through a 4D object? Well, any slice through a 4D object is a 3D object. So when you can imagine doing, say in that 3D grapher, you could do slices through a 4D object where each slice is a 3D object. And that way you can... no, it was fine, Tony. It was fine. So anyway, let me see. I'm kind of... Can I... Oh... all right, what I'm going to do is make something called Y1, which is this. I'm going to try this out because I'm really curious to see if this works. I was going to work on... All right, but this is all fun. Look at this. See, look at all these kinds of slices of things. It's amazing. We do this, we do over here Z1 equals this, because then I'm going to try stacking 2 rotations, because I need to rotate the cube around 2 axes. Z1. So I'm going to just turn that off. I don't need that. So there we go. We've got, right. So now I should be able to do a second angle rotation, which would also be 45 degrees. Let's call this B anyway. So I do cosine B plus sine B, and plus Y1 sine B. Am I having too much fun yet? Is somebody going to make this illegal? You have been accused of having fun with mathematics. How do you plead? You can see, look at this. You can see how that's a slice through my cube that's been orientated in a thing. Because Mike would not accept my crazy idea. Okay, so we can do rotation here too, but now if I am right, if I rotate both by pi over, oh, that's so disappointing. If I get the rotation right, what I should get is a square all the way through the Z, because you're taking slices. I've aligned the cube, and something's gone wrong there. It doesn't look like it's aligned properly, which might be to do with, well, a bug actually, I suppose. I've got Z1, Y1 calculation, which I did on here, and then it's cosine B plus Y1 sine B plus y1 cos b minus x sine b. It should be fine. It's probably got to do with interactions between the two rotations that I can't visualize. So what I'm going to do is just experiment. There must be a certain rotation where you end up with a cube. No. No, that doesn't happen. Oh. Yeah. Yeah, you know that first rotation? Oh. All right, if I set this to 0, not 0.1, 0. Can I have 0, please? 0. Thank you. Yeah, it shouldn't be doing that, because if I've successfully rotated my cube 45 degrees, it might be on its end, but slices through it should be consistent, and it's not, which actually means that this first rotation, there's something wrong with it. It's interesting. It's funny because you can actually see that there's a rotation. You can see it's trying to rotate it. I don't know why that isn't working. I would have thought it would. There's something to explore later. Can you see it looks like a rotation? I'm taking a slices through a rotating 3D object. If I stop doing the slice, how about this? It's like I'm just getting the, look. There you can see, it's the end. It's just the little end of the cube just cuts into the visible range. You see, it's just go in the same direction every time. See, what? That's the weird thing. Well, there's a way of checking, because clearly, if I align this thing right, that would be where the cube has a minimum, where we see a minimum size, right? Which should be there. I don't understand why. Oh! 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 I'm being stupid. Isn't it? It was. I don't know. Yeah, I thought so. That's what I thought. It's what I'm trying to do. And what I don't understand is why it doesn't work. So I'm trying, it's an exercise of visualization on here to go, okay, you've got your cube, it's on its side. This is where we need this 3D graphing thing, but it doesn't like my equation, it won't plot it. I'm being too clever for it. Oh, unless, oh. Oh, wait a minute. You know, I've been stupid. I did something wrong. Maybe. There. Plot it. No, you see, it doesn't like it. It's not plotting it. So, on its end. It's too. Yeah, look, it's 10 past 11 here. It's like, you know, I'm trying to do visualizing a 3-dimensional slices through a 3-dimensional cube, but I can't. It should work. If I apply a 45-degree rotation, it should. Yeah, I'm with you. It should work. So why it doesn't, I don't know. We'll do pi equal pi over 4. What I get instead is this. It is right. It's right. At least you can see the height isn't changing. It's because, okay, you can see what the shape is there. Then if I want to finish this rotation, I need to apply a second rotation around which axis? Oh, I need to rotate it around the y-axis. I think I can see the, can you see the cube there? It's on its edge. It comes in, boom, like, boom, boom. Well, if I want it to not do that, I need to rotate it around this axis. That isn't what I was doing. I was rotating it like this. Okay, hang on, there is hope. If I get rid of that second rotation, it was la, 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 la. And this one is la, 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 la. And now we have this, where I applied a rotation already. No, yeah. Right, yeah, so this first rotate, right, what's the first rotate? Oh, I rotated it in the YZ plane, that's correct. And now I need to rotate it in the YZ. I already did the YZ. Hang on. Oh, brain ache. YZ was the first rotation. Now I want to rotate around the y-axis by 45 degrees, which is XZ. So that would be, okay, damn it, X cosine B plus Z1 sine B, and this one is Z1 cosine B minus X sine B. So I'm now rotating it around the y-axis. Come on. Whoa, that's not, is it? God knows what that is. Cosine sine B. I don't think this is going to work. Oh my word. Pi over 4? Seriously? It's really refusing to comply. That's it. What's the equation of a cube? Well, John, I've given you the equation of a cube that's rotated awkwardly, and I can't figure out how to rotate. I'm trying. There's something that I haven't figured into this, or I've just got a bug. X, I'm rotating around the XZ plane. Yeah, okay. I can see defeat on that one. Anyway, that was a very interesting aside, wasn't it? So you just close everything down. That's it. Yeah, Desmos, hate Desmos now. So. I was going to work on my. I've only got 20. I've only got 40 minutes left because I have to organise my time now a little more carefully. Because I'm trying to fit in the music as well, you see. And then I have to go to work. I have to get in a little earlier. And I'll get up earlier. So it's like, yeah. Where was I yesterday? I was dealing with the response of something or other. Here was Emacs. I was trying to, if I run my build, let me go blah, 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 blah. Still takes ages for it to start up, which is really aggravating. It's like, give me a window. Right. And then we go to here and I hit refresh and it crashed my app because I get a select error. And I remember why. It's to do with flushing. I had to flush the buffer. I never implemented buffer flushing. Blow my nose. What's the equation of a cube, John? It's uncertain. It's only John. When I see your name there, I always think of Heisenberg. Heisenberg's uncertainty principle. I don't know why. I look at it, it's like John Heisenberg, but it isn't. It's Heisenberg. What's the origin of the name? So it crashes because there was a select error. That's on line 149. The error occurs because the socket was closed. So when I get the connection, it's a little complicated, this, because I have a list of update. I need to remove it from the list when I update. Socket update. Oh, I don't want to do the removal just yet, because that can be a pain. You socket update socket. All right, let's have a look at the data type for socket. Data type for socket, and here I need closed. Let's just do that. Now when I create a socket, but somewhere it's going to have to do that when I get a connection. It must be somewhere else as well. New connection. Let's have a look at the type for connection. Socket.h connection. Oh, we use socket handle. Oh, there's a disconnected. Okay, actually, so I don't really need that at this time. Start again. There is a disconnected. There, con1 read write. You close the socket when it's disconnected. Clean up disconnected sockets. I already handled that. So I already did this code. Close. So socket close. Close socket. Disconnected equals 1. So I think, oh, damn. Having trouble switching my brain to the copy and paste of Emacs here. Right. Where was I? I need to do that. So let's see if this works better. It comes along. There we are. I hit refresh. Dong. At least it didn't crash this time. It said empty response. Why? Let's have a look at the values. It's sending back an HTTP 200 OK content type, text HTML. Let's go back to using text plain. Connection closed. I don't know why I need that. If I do access control, allow origin there, and then over here we do right end of headers, and then we say ha ha. Ha ha. And run again, get that up, go hit refresh. Yeah, it's saying empty response. Because I closed the socket, if I get rid of closed socket and try again. Now when I do this, I don't get any response. Yeah, that's the weird thing. There is a response, but the response is empty. And that's what I was trying to figure out, is like, how do I get the response? It's not reading the body of this. And the, can I, oh, yes, right. I think I know what I can do to try and fire up GDB. No, it's not going to help. How would that help? It's really difficult to test network code with a debugger. Really nightmare. You're better off using logging generally. But this is what I'm going to do, is I'm going to try restarting that and then emulating it by using netcat. This is really nice, you see, because that's this. Then I can just go in and say, all right, we have to do our request, and what did the request? Oh, yeah. Well, it doesn't matter. What did I? Ah, yeah. It's not really. It doesn't really care about. Because it's a fake web server, it doesn't really care what I say to it. It just waits until there's a blank line. Then there's a blank line, and there we are. You can see that's what it did. It came back and it said HTTP 1.1 200 OK content type text plain access control allow origin star blank line ha ha. That should be good. That should be good. So I've got a little mystery to solve here. Now I thought it was because the socket needed to be flushed, but as you can see, I got the information. Let's try again. I'm going to do the same thing, right? Blank line. Now I'm just closing the socket, and this time when I close the socket, it actually doesn't transmit the information. So this matches what I saw because it said, oh, I've got no data back. I think it needs to close the socket. That's weird though, because you need to close the socket, but I do get a response. Ah, that's frustrating. Here, empty response because I'm flushing that, or closing the socket. So let's not close the socket. I do this again, and look, I got a response. But maybe it could be that I just need to flush the buffer. Let's do a lot of lines with ha-ha in them and see what happens over here. We do body used, you see, false. There probably should be a body in here, a readable stream. So the next thing I'm going to do is check something. Ah, yes, there is another thing I can try actually. Quite a simple idea. Instead of where's my page? There it is. This is the Desmos page I'm using to try and connect to the thing. I can just tell it to fetch something from a web server. I mean, duh. Let's get something from eBay. Like so. So I'll go to a website. What happens? It probably does cause policy. Ah, yes. Access to fair chat, blah, blah, blah. I need to access them. I need some kind of website page thingy that doesn't care, or I go open up a version of Google Chrome, create shortcut. No, I use a different properties, Chrome, disable security. Disable web security. I don't know, we can try it. Disable web security. So be careful, everybody, because as soon as I open up this Chrome browser, I will have disabled the security of the web. So everyone be careful. Oh, except it didn't work. How do I know it didn't work? I didn't get the warning. Okay, flipping heck. Disable web security Chrome. Okay. think I had to close all Chrome browsers. That's the problem. Oh, wait a minute. Maybe not. You're using an unsupported thing. I seem to have lost the chat as well. Let me get that back. Where be the chat? Where's the chat? Where's the chat? Here's the chat. Where's the chat? Where's the chat? I'll just open up the chat again. Yeah. So in here, this one, I can go right. More tools, developer tools. This is it. Console, hit thing. Okay, so now I've got a reply from eBay. Yeah, it doesn't matter. I'm still not got the body. Look. So the problem actually is this construct. I need to get the documentation on it because that's the problem. Fetch JavaScript read URL. How to use the JavaScript fetch API to get data, because we get a response, but the response we get is not JSON, but an object with a series of methods we can use depending on what we want to do with the information. These methods include clone, redirect, array buffer, form data, blob, text. Oh, text. Fetch the URL, then JSON, then function data, return who is map create. It's not exactly clear how that's supposed to work, is it? Text. Okay, well. Is it just text? Can I just do that? Data text console. Okay, text. Will that work? I'm kind of skeptical that that will work because I should be able to see the data, surely. You know, promise, pending. Pending. Yeah, it's waiting for it. Okay, what happens if I shut it down now? It says correction read. Uncaught in promise type error failed to fetch. It's waiting for the information, so I think it. That's something I don't understand about this API. Looking at all these methods, the one we want is the JSON one because we want to handle our data as a JSON object, so we add. Transform the data. Well, let's just try it without understanding how, why. If I follow the pattern, what I want is text, then response becomes that, and then we do function. Wait a minute. Fetch, then response, then function data. Okay, but how do I get the data? When I look at how it does it here, data, where do you get the results? Data results, okay. Is it really seriously? What a strange API, which is no longer a function, but come on. Well, there's nothing. It's printed nothing. Connection reset. Okay, then let's try this again with eBay. Which I have to run in my, oh, I closed that down. Where was it? This one. Using unsupported command line thingy thing over here. Boom, 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 boom. Boom, boom. Developer tools. It's kind of interesting that it just fails to get the data, even from eBay. Okay, let's try and look. JavaScript, read text, plain, example, fetch. Then function response. Right, let's use this example. right? And then console log stringify my JSON, but I don't have JSON in this case. So when I do function response, return response text, then function my, where did my JSON come from? Then function, oh, text console log text. I just want to read it back as text. How hard can that be? Oh, that looks more like it. Advanced search 2, Virgin Media thingy, whatever. Anyway, look, whatever happened. Oh, because /com. I think it's working. There is the eBay page. So, okay, that's progress. Let's go back to HTTP localhost port 2002 /K1 equals 0.5. Let's see what happens. So I go over here, I hit refresh, and we get nothing. Man, nothing. Error connection reset. So what's happening here is I'm failing to close the connection properly. There's connection refused because I wasn't running the app. And on this one, ta-da, it's sitting there waiting for the response. So I need to figure out then how to close the connection without it here. Well, let's try this first of all, because it could be that there was a problem. All the other crap was causing a problem. So we try this. Beep, beep, beep. No. It's empty response. So let's have a look at my socket code. And we need to see if I've got anything doing flushing. Flush. No. How do we close the connection? I said close socket or the connection handle. But what I probably need to do is flush WinSock flush outgoing packets on close. Flush TCP socket. Please clarify what you're going to do. Disable. No, going to find someone else. Close. Close socket directly after send. Let's have a look at the close socket code. Let's just close. Yeah, it should. That's really frustrating. WinSock. Right, so this is the WinSock close. Socket function closes a socket. Use it to release the socket descriptor passed in the S parameter. Note that the socket descriptor passed with the S parameter may be immediately reused as a result. Blah, 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 blah. WinSock client, blah, blah. Any pending overlap send and receive operations, WSA send to blah, 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 issued by any thread in this process are also cancelled. Any event, completion routine, or completion pull, blah, 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 blah. An application should not assume that any outstanding I/O operations on a socket will all be guaranteed to be completed when closed socket returns. The closed socket function will initiate cancellation of the outstanding I/O operations. That does not mean that an application will receive I/O completion to these I/O operations by the time closed socket returns. Thus, an application should not clean up any resources referenced by outstanding I/O requests till the I/O requests are indeed completed. An application should always have a matching call to close socket for each successful call to socket. The Linga structure maintains information about a specific socket that specifies how the socket should behave when data is queued to be sent and the close socket function is called on the socket. The L on-off member of the Linga structure determines whether the socket should remain open for the specified amount of time after the close socket function call to enable queued data to be sent. This member can be modified in two ways, called the set sock op function with the op name parameter set to so don't linger. Op val parameter determines how the L on off member is modified. Call the set socket function with the op name parameter set to so linger. The op okay. God. All right. So how do we do that? Called the set sock option. Set socket option. Set socket, listen socket, when keep alive. Blah. Okay. Messy API. Okay, well, let's try it. When I go and do create the socket, which was on connection, when there's a new connection, on set socket, update socket, no, here, blah 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 blah. I'll be able to do it. Right, so this is in update. You create a new socket. Yeah, so here's a good place for that. So what I'm going to do then is try to call set socket option with the socket, which is con handle. Con handle level. What's the level then? Level at which the option is defined. For example, SOL socket. Well, I guess. Next parameter, opt name. And so the opt name is going to be lingers on close if unsent data present. That's linger. Next parameter is the const char star opt val. Opt val, a pointer to the buffer in which the value for the requested option is specified. If I go keep alive, no, linger structure. I have to create one of these. I have to create a struct linger. So here we go, struct linger. struct linger. Alright, and in here we do L on off, use short, specifies whether a socket should remain open for a value non-zero. Okay, so let's just make that 1, keep it simple, non-zero, 1. Next one, L linger, linger, use short, linger time in seconds. Okay, so we're going to linger for 5 seconds, right. And then blah, blah, blah. What else do we need? Nothing else. We can try this. Then what I need to do is put in here and lin, and then get back to this function. And then there's opt-len. Opt-len, the size in bytes of the structure pointed to size of struct linger. We try to set this socket option. So with a bit of luck, this will be the problem, is my guess. Let's see, go on there. Right, okay, doesn't work. Why? Because function incompatible types. I was expecting that one. So let's go to convert to a const char star. And what have we got? Next problem, missing. Ooh, we got a bit further. Missed a semicolon. Next, try again. Yeah, okay, compiled. Let's go back to over here. We hit refresh. And we've got empty response. This is going to run and run, this one. Send. I send it. I close the socket. It's supposed to linger, but it ain't lingering. It's malingering. It's not lingering. Empty response. Ay. Close socket. We go to that. Socket. There we are. We'll say disconnected. Let's try not doing that just yet. See what happens. On there, refresh. That causes it to crash. Of course. Windsock flush. Not getting there. What does keep alive do? Yeah, it's a little bit of a mystery. It is indeed. Why this doesn't work. Linger. Non-zero. Socket will remain open for a specified amount of time. To disable a socket from remaining open if the application calls. Graceful shutdown, linger options and socket closure. The following materials provide as clarification for the subject of shutting down socket connections, closing the sockets. Important to distinguish between shutting a socket down a connection and closing a socket. Shutting down a socket connection involves an exchange of protocol messages between the two endpoints, hereafter returned to as a shutdown sequence. The two general classes of shutdown sequences are defined: graceful and abortive. In a graceful shutdown sequence, any data that has been queued but not transmitted is sent prior to being closed. Okay, closing a socket, on the other hand, causes the socket handle to become deallocated. Windows sockets, both the shutdown function and the WSA send disconnect function, can be used to initiate a shutdown sequence, while the close socket function is used to deallocate socket handles and free up associated resources. Some amount of confusion arises, however, from the fact that the closed socket function implicitly causes a shutdown sequence to occur if it's not already happened. In fact, it has become a rather common programming practice to rely on this feature and use closed socket to both initiate the shutdown sequence and deallocate the socket handle. To facilitate this usage, the sockets interface provides the controls by way of a socket option mechanism that allows the programmer to indicate whether the implicit shutdown sequence should be graceful or abortive, and also whether the closed socket function should linger. That is not complete immediately to allow time for a graceful shutdown sequence to complete. These important distinctions and ramifications of using closed sockets in this manner are still not widely understood. By establishing appropriate values for the socket options SO linger and SO don't linger, the following types of behavior can be obtained with a closed socket function. Abortive shutdown sequence, immediate return from closed socket. Graceful shutdown, delaying return until either shutdown sequence completes or the specified time interval will elapse. If the time interval expires before the graceful shutdown sequence completes, an abortive shutdown sequence occurs and closed socket returns. You mean closed socket blocks? Closed socket returns. I don't like the sound of that. Graceful shutdown, immediate return, allowing the shutdown sequence to complete in the background. Although this is the default behavior, okay, the application has no way of knowing or whether the use of SO don't linger, socket options and the associated linger structures discussed in more detail in the Instead, use one of the explicit shutdown functions, shutdown or WSA send disconnect. This in turn causes FD close, indication receive, and to illustrate the what a mess. So there, lots of fun to be had there. But I'm out of time, so the witching hour has arrived. So yeah, a little distraction there with mathematics, but that's always fun, isn't it? I'll be back again tomorrow, all things being well, around about 10 o'clock. Thanks for watching. Take care, everyone. Good night.